Okay, it's great to see everyone here, and thanks so much for the kind introduction. So my name is Sandeep. I'm Chief AI Officer at Story, just recently joined. But moreover, I'm a Chief Scientist at Poseidon, which is a new incubation from Story that's backed by A16Z, and I'm super excited to be talking about today. And in another life, I'm an assistant professor at UT Austin. So broadly speaking, I work on generative AI, robotics, and distributed systems. And I've been thinking about the intersection of crypto and AI since my PhD days at Stanford. So today we're seeing a race to train the world's best generative AI foundation models. And there are actually three key ingredients to training these models. So the first is compute, but this is largely monopolized by NVIDIA and, say, AMD. But the second is model architectures. So at a first glance, you might think, well, model architectures are actually a point of innovation. But I would argue they're quickly becoming a commodity. So at the start, we first saw OpenAI using transformers, but then Anthropic quickly caught up. And now you're starting to see very small startups rivaling these incumbents like DeepSeek from China. So even if you have a short-term advantage, it might, say, stay for about 6 months. And if you peer under the hood, mostly people are just using transformers, diffusion models, or what are called mixture of experts architectures. But the third ingredient is the most important. That's the secret sauce to training these models, and it's data. And it's just not common data that I can just crawl from the web, but it's actually what we call long tail or unique data. So here in Korea, that could be somebody speaking at a call center in a rare dialect with noisy backgrounds, or it could be someone taking first-person video view of them doing manipulation tasks in their home to train a robotics foundation model. So if you look at the data space, there's actually no clear winner. Scale AI was doing quite well initially, but Meta pseudo-acquired them. So there's actually a void here, and that's exactly where we're operating at Poseidon. So the first wave of foundation models largely operated on text and online media. So they could write emails, they could maybe generate an image, but they largely were trained by scraping the web, often illegally. And this is kind of saturated. Everybody has access to these public data sets, say Common Crawl. So the need for new types of data is being echoed by some of the greats in AI. So for example, Ilya Sutskever, he's very early at OpenAI, now has his own billion-dollar startup, Safe Superintelligence. He's basically saying that we're running out of data. This is echoed by Elon Musk. And you might think that synthetic data is good, but it's actually just regurgitating some of the data we already have. So that's not enough. So the next wave of foundation models are multimodal. They're for physical AI. So they can understand video, they can understand audio, they should be able to ingest LiDAR, radar, and make decisions in the physical world. So they can potentially do your dishes in a couple of years, or maybe they can actually take safety-critical decisions in healthcare. But it turns out for training these models, you need much more data, and you need rare events, or edge cases, which we're calling long-tail data. So this is echoed by the CTO of Meta. For example, if you want to train a robot to advance the clicker like I'm doing, or hold the mic, you need millions of hours of video data that intuitively teaches a robot about the laws of physics. This is also echoed by NVIDIA and their humanoid robotics team. So this is the space that we're playing in for Poseidon. So fundamentally, Poseidon is an AI training marketplace. So what I mean by that is, in a two-sided marketplace, you have demand. These are foundation model companies that are looking for rare events, long-tail data, but you need to match them to supply. These could be regular Web 2 businesses that generate interesting training data during the course of their operations, but you need to match this demand and supply and search for it, which is exactly what we're building. And in our marketplace is tuned towards long tail, this rare data, but a key term here is IP safe. So what we mean is that contributors are rewarded fairly for their data, and it's rights cleared, so it's amenable and licensable to use in any AI workflow. So let's unpack what that means. So this is our AI training marketplace, but let's actually start with an example. So on the right here, we have demand. And we've been talking to some of the world's largest foundation model companies and have initial contracts with some of them. So let's take an example of training a voice AI foundation model that can generate, say, high-quality Korean speech or across the globe. So most public AI data sets, like I'll show, especially for voice, are heavily dominated by Western European languages. So I might need more examples of Korean, but people having conversations with background and so forth. So that's the demand, but how do I actually find the supply? This could come from a call center. This could come from individual DeepIn or decentralized physical infrastructure network apps, or it could be a host of different suppliers. For example, if I'm looking to train a robot foundation model that can dexterously manipulate objects, maybe I could pair up with a house cleaning service, and every person is going to wear a GoPro and collect data and earn passive income on the data they collect. So that's the goal. But the key question of interest is, well, how do I actually match supply and demand in this marketplace? So that's exactly what we're building in the middle. That's Poseidon's AI data platform layer. So the analogy here is raw data is kind of like crude oil, but I need to refine it and make it amenable to refined oil to use in an AI workflow. So specifically, I need to collect the data, I need to clean it, I need to use AI to label most of it, and only when I'm uncertain should I ask a human for help. And I need to organize this data so a foundation model company on the right can actually use it. That's exactly what we're building. So a natural question to ask is, where does Story land in all of this? So we need to make sure this data is IP safe. So let's take an example. Let's say I'm driving somewhere here in the city of Seoul. It's brightly lit, and I capture data from my dash cam. That's my intellectual property. So now let me send that data to someone, and let's say that image has a rare event. Say a traffic cone that has changed, a new traffic stop sign that confuses my computer vision model. So I need to send it to someone else to label that data, draw bounding boxes, and annotate what these rare events are. And that is also intellectual property. And now if I send that to someone else, or even an AI agent, they can create new variations or remixes of this data. So to stress test my computer vision model, I can generate that same raw image in fog, sleet, or snow using stable diffusion. But that's also, again, intellectual property. So if you look at this example, it has a graphical relationship. I have the original IP, which is the parent. The children are derivatives, which are the labeled data. And I have even more derivatives of this original IP, which are the new variations in different weather conditions. So to accurately encode this graphical nature of intellectual property, which is also programmable, you need a layer 1 blockchain like Stories L1 to encode these relationships. All right. So our vision is to build infrastructure to organize the world's training data and actually bring it on-chain. So you can think of subnetworks specialized for different AI tasks, from robotics to audio to even highly specialized text, in order to serve foundation model companies. So that's a very grand vision, but we just started 3 months ago at Poseidon. So our first project was to build a reference implementation. This is our voice DeepIn app, and it's a proof point that we can capture large amounts of data in just 2 weeks. And this is just an example of our much larger vision of a data economy. So let's see how this works. So this is an example from our voice app, but everything we're doing at Poseidon is based on demand. So we're having deep conversations with foundation model companies. We've talked to several of them, and they say, look, we need more audio data in rare contexts, underrepresented languages, noisy environments, and so forth. So everything is based on the customer. So this is our app. And what's interesting here is if we just open this up to the community, you'll get very high-profile people using it. For example, I believe the CEO of SK has used this. But also, you might actually get some spam. You might have people using text-to-audio models, or people just recording the radio and trying to get some rewards. So how do I mitigate this is very interesting. It's some research I'm leading at Story and Poseidon on AI meets cryptography. So the first example is, imagine if you have a seed phrase that is uniquely tied to your wallet ID. Then I can have the user surgically insert this text, and this is some sort of fingerprint or digital watermark that the data was actually authentic. This is what we've actually implemented. And let's see how this does on large amounts of data. So we have several data campaigns. One of the most interesting is actually here in Korea, the Korean voice data campaign. And you can see here that users have to read a predefined transcript along with their seed phrase. And this is a very general platform, so we've had many different languages. And it's staggering to me to see the amount of data that we've collected. So as an academic, I'm used to very small data sets that are hard to procure for years. But in just 2 weeks, we collected about 35,000 hours of audio data. That amounts to 5.5 million unique submissions and about 400,000 unique contributors that are geo-distributed worldwide. So, as I mentioned before, this audio data is not ours. It's actually intellectual property of a user. So this is all being transparently tracked, and there's the Story blockchain to track the provenance. So this corresponds to about 3.75 million IPs registered on Story, and the Poseidon app became the top AI app on the World Store. So the key question of interest is, how good is this data, and does it actually improve the state of the art of AI today? So this is where some of our deep research comes in, where the x-axis here is different languages of interest, and the y-axis is the number of audio data hours that we've collected. And notice it's on a logarithmic scale, so actually the differences are much more exaggerated. And in blue here is the data we've collected from Poseidon, and then the orange is all public data sets combined. And clearly we see here that in public data sets, English and Western European languages are heavily over-prominent, but even for many of them, we dwarf the amount of submissions. But if you focus your attention here, Korean data is very underrepresented, and we have an order of magnitude much more. So now let's actually break down why this is happening. So if you look at the previous bar, blue was Poseidon, and I broke this down into public data sets from household big tech companies. So the first is Common Voice, that's from Mozilla. Then you have Google's Floors and Meta's MLS data sets. And the key point here is purple is actually the Vox Populi data set, which is people speaking in Western languages in parliaments. So notice here, very few data sets languages are represented by all data sets. And if you see the Korean language or some Indian languages, they are highly underrepresented, and that's why we're doing well. So this is just an example. We are much more than a DeepIn app. We are a data infrastructure play. So our goal is to bring all the world's AI training data on-chain, and this is just a reference implementation. So we envision a world where there are different subnetworks or some communities. Some are geared towards health data, some audio, some highly specialized text from lawyers, doctors, and so forth. They all sit on-chain, but they're using our shared data infrastructure. So this is an example. This is what we're calling a subnet, or a specialized data economy. So let's take an example on robotics. To train a robot foundation model, I have highly specific requirements. So we're talking to some of the foundation models, they need egocentric video, they need depth information, and they might even need audio. But then that's somewhat similar to what you need for healthcare. You need video, you might need audio, but you also need time series data, say electrocardiogram or ECG signals. But privacy is a big concern. So rather than reinvent the wheel, we have these different specialized subnetworks. They're all using our common data infrastructure on the bottom, which has a uniform way to organize this data, clean it, label it using AI, and selectively use humans only when AI is uncertain. That makes it much more cost efficient. And I'm really excited to formalize this in our light paper. We are going to publicly release it next week, but it's actually based on deep conversations with foundation model companies, breaking down the need for training data, why training data is a fundamental form of IP, and the connection with Story and Poseidon, but also it's a reference implementation, kind of galvanizing the community to build more of these subnets and how to do so. So please read our white paper. And with that, if you have any training data needs, and if you just want to chat, please reach out. Thanks for your time.